A ray that penetrates the skin, enters into our body, and makes us see what we can't see through our naked eyes. A ray that makes us believe that our flight will be safe. A ray that has reached deep into space where even an optical telescope can't reach. And these rays also tell us about the activities on these heavenly bodies. Science and technology give birth to new discoveries and inventions every day. Out of these inventions, there are some that give a new direction to mankind. The discovery of X-ray is one such discovery. The discovery of X-ray was a coincidence, but today X-rays are used everywhere, from hospitals to airports, from physics to microbiology lab, from the remote reaches of space to the depths of the ocean. X-rays were discovered around 100 years back by a German scientist, Professor Wilhelm Cannard Roentgen. 8th November 1895 was the day when Roentgen was studying the characteristics of cathode rays in his lab in the University of Würzburg. Suddenly, a ray of light in the far-off corner diverted his attention. He found out that the light was coming from the screen coated with barium platinocyanide. Though Roentgen knew that if the screen is exposed to cathode rays, it brightens up, but what amazed him was that the cathode rays tube with which he was working was covered with a thick piece of cardboard. Roentgen inspected the whole room and found no other source of light there. He got disturbed. At last, Roentgen turned off the cathode ray tube itself, and the result was shocking. The screen stopped glowing. Roentgen turned on the tube again, and again the same mysterious light. Roentgen knew that the light was related to cathode ray tube, but how? This he could not understand. But yes, Roentgen knew that cathode rays did not have the ability to penetrate the cardboard, so he was sure that cathode rays were not the direct reason. To understand this phenomenon, Roentgen did not come out of his lab for many days. Neither did he meet anyone, nor did he speak to anyone. He just kept on trying to understand this mysterious process. He experimented with wood, metal, and came to know that this ray is capable of penetrating many types of material. In these experiments, he found out that this light travels in a straight line and does not get deflected due to magnetic fields. One day, while working, Roentgen put his hand between the cathode ray tube and the coated screen. This time, Roentgen was a little scared when he saw the shadow of his hand on the barium platinocyanide screen, in which the bones of his hand could easily be seen. Roentgen immediately realized that he had discovered a new ray. He called it X-rays, because these rays were too mysterious for him. Roentgen was not the first scientist to see the X-ray. Before him, Henrik Hertz's friend Philips Lenard had seen X-ray, but he failed to understand it. When Roentgen first saw the rays, he did many calculations and experiments, and only then displayed his discovery to the world. It not only shows his dedication to science, but is a classic example of the right method to understand science. On 22nd December 1895, Roentgen called his wife Bertha to his lab, and he took the X-ray of her hand. It was the first X-ray in human history. Roentgen was honored with the Nobel Prize for Physics. He was so generous that he refused to patent the X-ray, and not only this, he even donated the entire money to the University of Würzburg. Both X-ray and visible light are electromagnetic waves that radiate in the form of small packets of energy, which we call photon. Basically, these electrons revolve at different energy levels in an atom. The outermost orbits have the highest energy level, and as we move in, the energy level comes down. When electrons fall into the lower level, the extra energy comes out as photon. This process is called characteristics X-ray. In another process, when charged particles are suddenly stopped, energy comes out of them in form of X-ray, which is called Bremsstrahlung X-rays. The main difference between X-rays and visible light is because of the wavelength. The wavelength of visible light is more, but energy is less, while the wavelength of X-rays is less and the energy is high. It can be explained more vividly with the help of electromagnetic spectrum. Through this spectrum, it can easily be seen that our eyes can see light with wavelength ranging from 400 nanometer to 700 nanometer. Light with a wavelength above or below this can't be seen by our eyes. Radio wave, microwave, infrared are on the lower side of the range. Ultraviolet rays, the X-rays, and gamma rays are on the upper side, which we can't see. Now the question is that how can we see bones through X-ray? Actually, the soft tissues of our body are made up of small atoms in which the distance between different energy levels is not much, and electrons don't need much energy to change their positions. That's why these tissues are unable to absorb the photon of X-ray, which penetrates them and moves ahead. But our bones are made up of calcium, and the size of calcium's atom is big. To send electron from one energy level to another, big amount of energy is needed, which is present in the photon of X-ray. When X-rays collide with bones, they are absorbed there, and this is the reason that bones can easily be seen. Discoveries and inventions of science are not miracles, but are the results of hard-worked calculations and serious experiments. Though X-ray was discovered by Roentgen, its credit goes to all the scientists whose inventions made the way for Roentgen easy. The electric machine made by Faraday in 1850 and induction coil made by Ruhmkorff in 1851 were both an important part of Roentgen's lab. Sprengel made the mercury air pump in 1865 that Roentgen used in his experiment. This mercury air pump was continuously used to vacate glass tube, and that is how we came to know about cathode rays. The series of inventions and discoveries kept on going, and in the 8th decade of the 19th century, William Crookes developed the Crookes tube. And there were a glass tube which was in the form of a sealed cylinder, and there were electrodes in both of its sides. Crookes used a better vacuum pump, because of which a better cathode ray tube was formed due to the low atmospheric pressure. After that, new mysteries about cathode rays were revealed from time to time. Hendrik Hertz showed that cathode rays could even penetrate thin metal. On 28 December 1895, Roentgen showed his discovery to the world. He prepared a report on a new kind of rays. In this report, Roentgen gave radiograph of his wife Bertha to the president of Würzburg Physical Medical Society. On 1st January 1896, he sent this report to all his scientist friends in Europe. The whole world was amazed at the discovery of X-ray. In newspapers, magazines, cartoons, ads, everywhere, these mysterious rays were discussed and talked about. In each and every town of America, X-ray studios were opened and people were coming to get their X-rays done. On one hand, X-ray was used for entertainment and fun, and on the other hand, medical science was studying X-ray to use it for good purposes. Just after 4 days of Roentgen's revelation of X-ray, it was used to spot out a bullet in the leg of a patient. Many X-rays were taken for bone fractures and stones. Doctors put metal rods in the body to find out the correct structure of organs and blood vessels. Later on, X-ray therapy became an important part of the electrotherapy books. The world was learning good things about X-rays, but soon negative impact of X-rays was also visible. In February 1896, the physics professor of Vanderbilt University took an X-ray of the medical school's dean. Within 3 weeks, all his hair fell off. Nobody took this seriously, but people started thinking about it when such reports started coming from other areas. Symptoms like redness on face, hair fall, infertility, and severe pain were related to X-ray. The fact that X-rays could kill came to be known in 1903, after the death of Thomas Alva Edison's helper Clarence Daly. Daly used to work with X-rays equipment, and he died of skin cancer. New experiments were started after his death so that X-ray could be used for treatment without any harm. Modern science had now understood the use of X-ray. The mysterious ray of Roentgen came out of the dark room and became an important part of the scientific world. This journey that started from bones has now reached to organs, muscles, blood vessels and corpuscles. With the help of CT scan, 3D images of smallest organs of body could be taken, because of which the roots of many dangerous diseases could be found out. In modern science, the revolutionary contributions of X-ray include the revelation of crystal structure DNA and protein molecule. W.H. Bragg and W.L. Bragg developed the technology of X-ray crystallography. They made a special vacuum tube, and the extra energetic X-ray coming out of it was collided with the crystal. When X-ray collided with the electrons of the crystal, the X-ray started radiating from it, which gave the clear image of crystal. Rosalind Franklin and Henrik Wilkins understood the physical structure of DNA molecules with the help of X-ray diffraction only. In this connection, the most important name is that of Dr. Ramachandran, one of the best crystallographers and structural biologists of his time. The triple helix model given by him helped in understanding the structure of fibrous protein. By using X-ray diffraction, Dr. Ramachandran played an important role in understanding the protein structure. On one hand, X-ray helped in understanding crystal structure and DNA, and on the other, it also contributed in measuring the depths of space. The X-ray radiating from space came to be known in 1949, when a radiation detector found the X-ray coming from Sun. After that, astrophysicists started working on the cosmic X-rays. In this series, X-ray telescope was built. The X-ray radiating out of space do not reach the Earth. That's why X-ray telescopes are sent to space. X-ray telescope basically finds out the direction of X-ray and the amount of energy in photon. First X-ray telescope was made in Cambridge in 70s under the supervision of Riccardo Gicconi. Apollo telescope mount was the first long-focal X-ray telescope. Then in 1978, NASA launched Einstein X-ray Observatory. This X-ray telescope discovered 7,000 sources, out of which X-ray radiates. The first photograph of Milky Way and gases present in it was taken by this telescope only. In 1990, a satellite called Rosat, named after Roentgen, was sent to space. Through this telescope, 60,000 sources of X-ray could be found. NASA's Chandra X-ray Observatory, named after renowned Indian astrophysicist Dr. S. Chandrasekhar, is the most important link in the history of X-ray astronomy. This observatory was launched by Space Shuttle Columbia on 23 July 1999. Its telescope is equipped with 4 sets of nested mirrors. These mirrors can find out the X-ray sources which are at double the distance. Chandra Observatory has taken several images of Milky Way, supernova, black holes, and gave a new meaning to our imagination of space. After more than 100 years of its discovery, X-ray has crossed some important levels, and there are still more to come. The interest of scientists in X-ray is still the same as it was 100 years back. The only difference is that today the subject of experiment is not bones, but DNA, which is an important part of our body vessels. Today, we are exploring invisible bodies of space that even the best of telescopes could not see. Many mysteries can still be solved with the help of the older discoveries. Maybe one of these mysteries gives a new direction to the human history. No other source of light there. He got disturbed. At last, Roentgen turned off the cathode ray tube itself, and the result was shocking. The screen stopped glowing. Roentgen turned on the tube again, and again, the same mysterious light. Roentgen knew that the light was related to cathode ray tube, but how? This he could not understand. But yes, Roentgen knew that cathode rays did not. A ray of light in the far-off corner diverted his attention. He found out that the light was coming from the screen coated with barium platinocyanide. Though Roentgen knew that if the screen is exposed to cathode rays, it brightens up, but what amazed him was that the cathode rays tube with which he was working was covered with a thick piece of cardboard. Roentgen inspected the whole room and found from hospitals to airports, from physics to microbiology lab, from the remote reaches of space to the depths of the ocean. X-rays were discovered around 100 years back by a German scientist, Professor Wilhelm Cannard Roentgen. 8th November 1895 was the day when Roentgen was studying the characteristics of cathode rays in his lab in the University of Würzburg. Suddenly, science and technology give birth to new discoveries and inventions every day. Out of these inventions, there are some that give a new direction to mankind. The discovery of X-ray is one such discovery. The discovery of X-ray was a coincidence, but today X-rays are used everywhere. A ray that penetrates the skin, enters into our body, and makes us see what we can't see through our naked eyes. A ray that makes us believe that our flight will be safe. A ray that has reached deep into space where even an optical telescope can't reach. And these rays also tell us about the activities on these heavenly bodies.